Hello everyone. In this short lesson, we will look at a horizontal projectile. A horizontal projectile is a projectile that is launched horizontally from a platform. So to illustrate such a projectile, we have a ball that is launched with a certain velocity v0 horizontally. Normally what we expect is for the ball to follow a projectile path such as that shown. Now at any time along the motion, the velocity of the ball has an x component and a y component. It is worthwhile for you to keep in mind that the acceleration of the projectile is vertically downwards, and that is because the only force in the absence of air resistance that strictly influences the motion of this projectile is the force of gravity that acts vertically downwards. So gravity here acts vertically downwards, and it's just equal to the mass of the projectile multiplied by the acceleration due to gravity. Now, because this is a two-dimensional motion, one of the best ways to analyze this motion is to analyze the horizontal motion independently from the vertical motion. And that is actually why this is going to be simple, because we're going to break it down. We're going to take a two-dimensional motion and break it down into a one-dimensional motion and make life really easy for us. So let us begin first by looking at the horizontal motion. I will just call this the x motion. So the first question you need to ask is, we need to first of all choose where our origin is at. Now there are two locations that are prime candidates. We could either choose our origin to be here, or we can choose our origin to be at the foot of the table. It really doesn't matter. Our answers actually will give the same, the procedure will give the same results. So let us take our coordinate. This will be our y-axis, and this will be our x-axis, and let this be our origin. From this, you can actually see that x0 is 0, but y0 is h, because h is the height of the platform. This distance from here to here is the range, which is the maximum horizontal distance traveled by the projectile. Remember, the range is the maximum horizontal distance traveled by the projectile. So x0 is 0, vox is just v0, and the ax obviously is 0. So these are the initial conditions. The initial acceleration in the x direction is 0. It starts at the origin, and the initial velocity in the x direction is just v0. So we know that vx is vox plus axt. This is 0. So this would mean that vx is equal to vo just v0. What this implies is that the velocity in the x direction doesn't change. Similarly, x will be equal to x0 plus voxt plus 1/2 axt squared. This will be equal to 0 plus v0t plus 0. In other words, x will just be equal to v0t. So if we represent this in the form of a graph, this is t, this is x, you would see that the horizontal distance increases linearly with time, and also you will see that the velocity in the x direction remains constant. Now similarly, this is ax, it's just 0, just essentially 0. So ax is 0, vx is just v naught, and x is v naught multiplied by t. So let's look at the y motion. In the y direction, we are looking here at the y motion. So in the y direction, we know that y naught is h, we know that ay is negative g, and we know that voy is 0. This is important. Why is this important? Because the object is launched horizontally, so there is no initial velocity in the y direction. It's important you note that there is no initial velocity in the y direction. So using the kinematics equations of motion, Vy is Voy plus Ayt. This is just going to be 0 minus gt. So Vy is just negative gt. In other words, the velocity in the y direction increases in the negative direction. So we have here y equal to y naught plus voyt plus 1/2 ay t squared. This is one of the kinematics equations of motion. Now let us substitute in things. We know that y naught is just h plus this is 0 negative 1/2 gt squared. This would mean that y is equal to h negative 1/2 gt squared, which actually defines this path. You can clearly see that when t is equal to 0, y is equal to h. When t is initially the ball is at a certain height h above the ground. Now as you can clearly see, as the time increases, what happens? H decreases. That explains why the path is the way it is. So this is a beautiful representation of an object moving in the horizontal direction. Now, if you want to represent Vy, it will look like this, t, as well as if you want to represent y as a function of t, it's going to look like that. That is h, which is basically this graph.